It's called MR-NH. Some automatic slides now. Afterwards, I explain the details. Of course, the printing shape, we compared it. And we compared the printed volume on the PCB. And of course, we did a lot of wedding tests, so how good we can solder. Very important is this offset print. I come later with some more details. And this is the product. Of course, it's a solder paste. Coming back to this result, we really, in this case, we are using this 150 micrometer stencil, and it's an 0201 chip component. I assume if you have such a product in your factory, very often I see step stencils with different thickness to solve the problem. And our goal was to develop a paste which is able to print such a challenging application, but also to print a complete normal product or normal component on the same PCB. And this is also what we collected from the market. What I said already, 0201, 150 micrometers. And please, normally you would use only 100 micrometer PCB for such a small component. But if you use 150, you have 50% more paste or 50% more solder material. And the solder joint reliability has a big influence. According to our experience, the solder strength of the solder joint is approximately between 30 and 40% higher. If you would use instead, if you would use a 100 micrometer PCB. So I have to accelerate. It's a little bit too, I talk too much. This is the result, the printing result of continuous printing up to with different diameters of the openings from the stencil. And with our paste, we have approximately, let's say, 80% printed volume. And this is a very good result for such an application. These tests we are doing with this special unit. It's called, we call it internally, it's a reflow simulator. So we can put the component inside this a very small chamber. It's here in the center. And we can make a movie during soldering. And so we can judge very good how good the solder quality is. This overprint movie, so we print more paste on the solder mask, and so let's say 50% on the solder mask and 50% on the PCB. And we check if all the paste coming back to the soldered blend and is not remaining on the solder mask. So this is, we call it gathering properties. And these properties you need especially for through-hole reflow application or for pin-in-paste applications. Like this example, or this example. Now you see a reflow process. You can follow the temperature. It's a pin-in-paste. It's a connector in a PCB. It's this connector inside our reflow simulator. Right-hand side, the solder paste already drips into the reflow oven. Maybe you know this. If you open your reflow oven, very often you can see in the preheat area, in the preheat zone, a lot of solder paste which is inside the reflow oven. And this is because of the chemistry inside the flux. And now the next movie is the peak temperature. Now it's very close to peak, now it goes up. So we fulfill IPC standard class 3. So the through-hole reflow process is 100% filled because there was enough solder paste which was, let's say, sticking on the pin. Or, yeah. So Anna, I have another 15 minutes. To give you let's say an entire overview about this product, of course we have to check the voiding properties. As you know, if you have a high power application, voiding is really a critical topic. And so we check the voiding ratio, especially for this transistor. And we are under 6%, so it's a quite good level. Yeah. And of course, we have to check the tackiness. Tackiness, you know what is tackiness? Let's say like a glue, it sticks. So the paste have to stick on the PCB that you can achieve a very good printing result. And so we have to check this tackiness strength. And also IPC has a value, I think more than 100 gram force, isn't it? I assume. Okay. So we are good, okay. This we have to clarify. And you can imagine if you have this tacking force, you have this printing capability, and last and not least, you have to have a good wetting property. Another value, SIR, I think you know it, what it is a surface insulation resistance value. So the resistance value of the residue which is left on the PCB. And this has to be more than 100 mega ohm. And we have, in the very beginning, I think it is 100 giga ohm. And then we put the PCB in a chamber, in a heat chamber for 168 hours. And after 168 hours, we have to measure this value again. And then the value, it's still 1-12 ohm. So it's 1-12, it's 10 giga ohm, isn't it? I think it's quite high level, yeah. So what I want to say, it's a very reliable and very safe product, also for the automotive industry or military industry. You don't have to clean the PCB. I know military application, you always clean, normally, because you are using a conformal coating. But from our point of view, it is not really necessary because the residue is really safe. These are the technical details. I think it's maybe not so interesting to go to all details, but I want to point out one important thing: viscosity. 110 Pascal second. It's a very low level, a very low value for solder paste. Maybe you have your value of your solder paste, what you are using in your mind. The typical solder paste has 200 Pascal second. So it's very much more stiff. This value is very low. Maybe you remember our video where I showed you these printing properties with a camera from underneath. And you can see the paste is really flowing. And you can only achieve this property if you have a very low viscosity. But now you have a problem. If you have such a low viscosity solder paste, if you remove the stencil, then it's maybe bleeding. And this was our challenge. And I'm pretty sure I say a lot of engineers are here in this room. I think you know what I mean exactly. Maybe to give all of you a better understanding about the value of viscosity. Water has 1 centipoise, it's called centipoise, a very strange unit. And ketchup has, for example, 50,000 centipoise. And this is a typical solder paste value. So now you have an idea about what we are talking. So now I come to how we could solve the problem. I cannot tell you all the details because it's our, let's say, our black box and it's our secret, but I can tell you the result. This is a typical way how to measure viscosity in the industry with this viscosimeter, and we have to calculate, we call it a thixotropy index. And it's a little bit a difficult word, very unusual value, and here you can see how it is calculated. So we measure at two different speeds. We measure the viscosity inside this machine. And then we set up a value, it is called TI, thixotropic index. Now it's getting a little bit complicated. Maybe you remember this viscosity value, 70 Pascal second. It's here. So this is the value when you are printing, because the viscosity is going down if you put energy into the solder paste. And then, because this is why you have to roll the paste before you start to print, maybe 1 or 2 times. Because the energy, you need energy inside the paste, because then the viscosity is going down. And then our, let's say our, how should I say, our goal was to find a special chemistry. If you stop to put energy inside this paste, the viscosity should rise up immediately, very high. So after printing, we have a very high viscosity. So our paste has this very special thixotropic index. So we were able to find a special thixotropic additive to make it happen, let's say like this. Yeah. Okay, I hope now everybody is confused. Any questions about this topic? Okay.